Alright guys, here's my video for 9.3 quadratics. And in quadratics, I want you to keep in mind you have two options to solve this quadratics. Option number one will be to finding the vertex using this nice little simplified formula. I call it the shortcut way. It goes directly to find the x value of your vertex, your maximum or your minimum of your parabola. And it's just the negative b all over 2a. And I'll go over this a little bit more in detail in just a second. That's option one if you want to go directly to the shortcut. Some students, I encourage for you to complete the square. Okay, use option two, which is completing the square. It is nice to keep this skill of completing the square all the time sharp, so you can continue using anytime I have a quadratic, I can complete the square to put my standard form of a quadratic in descriptive form. Okay, so let me talk a little bit about this right here. Anytime I have a quadratic in standard form, y equals ax squared plus bx plus c. Anytime I have a quadratic function, a quadratic given to me, I can find the vertex, the h and k of my vertex by using this little formula, x equals, okay, the quadratic variable here is x. So x equals negative b, so we take the negative value b here and we divide it by 2 times the a value in the front. Okay? So remember, quadratics, sometimes they open down and sometimes quadratic opens up. The vertex is this maximum value right here, h comma k, or this minimum value over here, which is h comma k. Okay? So this x value here that we are using helps us find the h coordinate of our vertex. So this helps us find the h coordinate of our vertex. Okay? Now if I want to find k, to find the k coordinate, I need to go back and plug in the value that I found over here, the negative b all over 2a, back in my original equation. So that is the discussion we had in class. First, this is a shortcut to be able to find the h, the vertex, the h value of the vertex, and then we go back and we plug it in to find the k value. What I need to keep to remind you is that we are not always going to be dealing with x. Okay, our formulas here, our quadratics, could be t squared, could be w squared, could be l squared, could be any other variable that we're dealing with to solve our quadratic equation. Okay, so keep that in mind. I'm going to bubble this because for this video, to make things run smoother and stay consistent, I'm only going to use this concept so I don't want to be flipping back and forth. Okay, so let's start with number 2. Okay, I did a similar example in class and I'm going to start again. So this is geometry. This unit is all about geometry, but there is a connection of geometry and quadratics. Okay, this is quadratic modeling. So let's take a look at it. We have a rectangular pen is made of 50 meters of fencing on 3 sides only. So I pretty much don't have a 4th side. The 4th side is a stone wall. So I'm going to write wall right here, and I am supposed to create a fence. I'm supposed to fence up 3 walls, 3 pieces here, and I'm not going to put a fence on the wall because the wall is already there. So they only gave me, for the perimeter to go around this area, this rectangular area, they only gave me 50 meters to work with. Okay, I have to make 50 meters fit this small space that they're giving me here, 3 walls, 3 fences. So find the greatest possible area that I can create. Of course, I could create something, let me just explore here a second on the side. Of course, if you give me a stone wall, I could create anything I want. I could create a really long area like this. I could create a really short but very, very wide area like this. Okay, so I have many options. I'm trying to figure out the best, most maximum area I could possibly create. This could be my width, this will be my length. This is my width, it could be my length. So I could have a long length and a small width. I could have a long width and a small length. So which one would be the best way, and that's what we're trying to figure out, is what would be the maximum, find the greatest possible area for such an enclosure. I'm trying to find out how can I optimize this and make the best area possible to plant something there, to do something with it, okay? They gave me 50 meters to be able to use 50 meters of fencing. All right, so let's go ahead and use the information they gave me for perimeter. So I have here this width, and this length right here, okay? I don't know how much it is, I'm trying to figure it out. So let's use the perimeter that we have here. So this perimeter formula has to fit my situation here. With my perimeter, I have to cover 2 widths plus 1 length. That's what I have to, that's what my perimeter, this is my given perimeter. Okay, that's what I have to work with. So I know that I have to cover 2 widths plus 1 length with this piece of material they gave me here, only 50 meters. So I'm going to come over here and I'm going to replace it. So 50 meters, I have enough to cover with 2 widths plus 1 length. Okay? Now my goal here is to isolate for one variable. I really don't care which variable you isolate, but always pick the easiest variable to isolate. To me, it's very easy to isolate for L. All I have to do is subtract 2 W's from both sides. Okay? If I subtract 2 W's, 2W minus 2W here is 0. I'll get my length all by itself. And on this side, I'll have my 50 minus the 2W. So there we go. I have the length nice and isolated. So now I can go ahead and move on to what they're asking me. They're asking me for best area possible. Okay? I know that if this works with 50 meters and this formula right here, I will be able to use the area, and the area is length times width. Okay? So I want to be able to write the area equation with only one variable. So I want to write the area formula with only one variable. I don't want to have to deal with 2 variables. I know that length is in terms of width here. So I can replace the length right in here because I know the length is already in terms of width, and I'll have an area formula with only one variable, which is width. So I'm going to replace the length with 50 minus 2 W's, and I'm going to keep that W already here. So my area formula is in terms of one variable only. The only variable I have is width. All right. So now I'm going to go ahead and distribute this. So the area is going to be 50W minus 2W squared. And now I have a quadratic. Okay, now I created my quadratic right there. Okay, I like to rewrite it because in quadratics we always like to see the squared term come in the front. So here we go. I'm going to write negative 2W squared plus my 50W. And that is just my quadratic that I created. Now that I have a quadratic, I can use my my little formula that I talk about for quadratics. Okay, I said whenever you have a quadratic, you can use this right here to find the vertex of your parabola. Vertex is the maximum or the minimum, and I'm trying to find the maximum area here. So now that I have the quadratic, I need to use this little formula: x equals negative b all over 2a. As long as I know what a and b is, I can use this. And I don't have x. The squared variable here is a w. So I'm going to use w instead of x because I want to find the maximum width. This is for the maximum h of my parabola. This is for my maximum width. I know that this is my a value and 50 is my b value. So I can go ahead and finish writing the formula. Negative is part of the formula. My value of b is 50. Divided by 2 times my value of A, which is -2. So now you can go ahead and finish this, okay? This is to find my maximum width. So look at this parabola over here. Let me rewind just a second. If you look at this quadratic, this parabola has a negative leading coefficient. So I know my parabola opens down, and I'm trying to find a maximum value, okay? Because of the -2w squared plus 50w, my parabola opens down. I'm trying to find the maximum. And that's what is helping me here. This little equation right here is helping me find the maximum width, okay? So now you can go ahead and do -50 divided by -4, -50 divided by -4. So we know that W is 12.5. That is the maximum width that I can have to maximize the area of my, my rectangle there. So now that we have width, I can go back and solve for the length. Because remember, the length right at the beginning, if you rewind a little bit, the length is in terms of W. And I know what W is now, so I can solve for the length. The length is 50 minus 2 times the W, which is 12.5. Now that I know that what the width is, I can solve for the length. 50 minus 2 times 12.5. 2 times 12.5 is 25. And 50 minus 25 is just 25. So there we go. We have our width of 12.5. We have our length of 25. And I'm pretty sure my area is just length times width. So 25 times 12.5. If you want to do that in your calculator, 25 times 12.5, you get, oops, let me do this right, 25 times 12.5 gives me 312.5. 312.5, and we don't know what we're dealing with here, units squared for the area. That would be 25 times 12.5, and that would be the area of our pen here. So that is for our number 2, find the greatest possible area of such an enclosure. So that would be the greatest area right here, okay? And that is the final answer, and that is how you work. I know this is a lot of work. You have to start with information of your perimeter. And then you have to write the perimeter based on what you have here. And then you have to isolate for one of those either lengths or width. So you can go and transfer that into the area formula. And then you have to somehow isolate and create a quadratic so you can find the maximum of your quadratic and so forth. So very, very detailed work, but pretty much the work stays the same all the time, okay? So let's see if we can do another problem that has to do with something different, okay? I was going to do number 5, but I'm going to let this be a discussion that we'll have in class. I want to move on to something different, okay? All right, so let's go ahead and talk about number 7. Number 7 here we have a ball is thrown vertically upward with an initial speed of 80 feet per second. Its height after t second is given. So let me go ahead and draw a picture over here so we can have an idea. We're always trying to visualize a problem. So I have a ball, someone is throwing a ball. I'm assuming this ball is coming from the ground, maybe kicking it, throwing it. So it really doesn't matter. The ball is thrown vertically upward, and then everything that goes up must come down. So there we go, the ball came down. Okay, so it forms this parabola, and we're trying to find the maximum height of this parabola. Again, we're trying to find the h and k value. So if this is a parabola right here, I'm going to draw an x-axis and a y-axis here. Okay, this ball was on the ground twice. This ball was on the ground at a certain time, and then again at another time. So I'm going to call my x-axis t, and I'm going to call how high it goes here. My y-axis is going to be height. Okay, height. So I have the height of the ball depends how long it takes to get there. We want to find how long, the t seconds, how long it takes for the ball to reach the maximum height. Okay, that's what we're trying to figure it out. So pretty much I'm trying to find the h and k, which is the vertex of my parabolas. But h and k here is no longer an h and a k, is my t time. So I'm going to replace with t for time. And h for height. I'm going to write height so you don't get confused with something else. So I want to know how long it takes in time to reach the maximum height of my parabola. That is pretty much what the scenario is here. So let's go ahead and use the formula they gave us. They gave us a quadratic in terms of height, which happens to be in our y-axis here. It equals 80t minus 16t squared. So let's go ahead and rewrite this so you can be familiar with the square terms comes in the front. So the height is negative 16t squared plus 80t. If I want to find the maximum time, so I'm going to use my little formula, t, because that is my squared variable, is not an x, is a t, equals negative b all over 2a. That is the formula I'm going to use to find the maximum time. How long does it take to reach the maximum height? Okay? So let's go ahead and identify who is b here. B is 80, and a is our negative 16. That's what our a is. So I'm going to do negative 80 divided by 2 times negative 16. Okay? When you do that in your calculator, you're just dividing a negative times a negative. So 80 divided by 32 gives you 2.5. Okay? So this is negative 80 divided by negative 32. It gives us 2.5. Since we're talking about in time, and they did tell us here in the homework that t is in seconds, this is 2.5 seconds. Okay? So it takes 2.5 seconds for this ball it takes 2.5 seconds for this ball to reach the maximum height. It started from the ground. So now I need to find what is the height. If I know that t is 2.5 seconds, all I have to do is go back and plug it in my equation for height to find out how high it will be at 2.5 seconds. So I'm going to have 80 times 2.5 minus 16 times 2.5 squared. Please be careful because you need to square it first and take things very careful here, okay? So 2.5 times 2.5 is 6.25 times the negative 16, and 80 times 2.5 is 200. And then all you have to do is do 200 minus, you have 16 times 6.25, which is 100. So you have 200 minus 100, so your height is just 100. Are they telling me the units here? T is in seconds, thrown upward, feet per second. So I know that the height is in feet. Okay? So as you can see, the steps here, if I want to rewind it with you, we have a quadratic given to us. Therefore, we can use this little formula over here to find the maximum domain while we're plugging in into formula. And this is our t value. We found the time it takes to reach the maximum height. And then we just have to go ahead and plug it in to find the maximum height. Okay? So hopefully this helps with this worksheet. You're always going to be using this little special formula here anytime you have a quadratic. This x value is not always x. It could be t, like it in this case. It could be w, like it was in the case before. As long as I have a quadratic, I can find what is the squared variable and use this little formula to find the maximum area or the maximum height or the maximum whatever I'm trying to find. Okay? So good luck with this worksheet. Let me know if you have any questions.